Hey, 7th grade, here we are in Chapter 6. This is the first lesson. This is Lesson 0. This is always the prerequisite knowledge, the stuff that you need to have success in this chapter. So let's go through these questions from your notes and see how you did. So we will start here with the true-false questions. Directions, write true or false for each example. First one, an algebraic expression and algebraic equations both use numbers, variables, and operations. That answer is very, very true. That's what they have in common. They've got numbers, they've got variables, they've got operations. So yes, that is a true statement. Let's do number 2. Equations are different than expressions because equations have equal sign. That's true as well. That is a true statement. Here's a way you can remember that. Equations start with EQUA, and the word equal starts with EQUA. So that's how you can remember equations have an equal sign. Equations are equating two different expressions and telling you that they're equal. So that's what's going on there. Great. Next one, number 3, equations can be solved using inverse operations. So I bolded this word solved here because that is very, very true. You can solve an equation, and to do that, we will use the inverse operation. So this whole thing here, yes, 100% true as well. And last but not least, number 4, expressions can be simplified, not solved. We just spent an entire chapter. Chapter 5 was all about expressions. Expressions do not have an equal sign, right? No equal sign in an expression. So because they don't have an equal sign, that means they cannot be solved. We can simplify them. So this is another true statement. So these are some really nice true statements that you can study as notes as you prepare for your upcoming quizzes and tests. So here is an activity for us. I would like to make sure that you copy this on paper. I know this is not part of your note packet, so take a minute, copy this down. These are some words that indicate that we should be using different math signs. So copy on the same diagram as me. You may need to pause the video for a minute until you get this copied, and then we'll drag some words into this diagram to kind of put words with their correct symbol. Okay, so I'm going to start over here. Per is a multiplication word. That's a word that I wanted you to be on the lookout for in Chapter 5 when we were writing our algebraic expressions. Per is still going to be very important for us as a multiplication word in Chapter 6. Another important multiplication word is product. Okay, another important multiplication word is each. We've got of. I think that's what I've got for multiplication right now. Okay, addition words, increased or increased by. Sum is a word that tells us to use addition. All together, that's an addition phrase. Total is a phrase for addition. And more than, that's another phrase that would tell us to be adding. Subtracting, we would be talking about the word difference, or maybe fewer than, or even less than, other words that are kind of like that. And then for division, we'd be talking about words like quotient or divide. So get those words on your paper, in your notes, just to help us when we're doing some of these word problems in the future. Another thing I want to draw your attention to here, I've got that word than underlined. Every time I see it, I want you to be underlining the word than when you see it as well. Let's take a look at what than tells us to do. Than is what we call a turnaround word. So when you see the word than, it's going to actually flip-flop the order of the two terms that are right near it. So let's do 4 examples here. Again, let's get this into your notes. This is some independent note-taking here. There is not a section for this in your note packet, but it would be awesome if you would take a quick minute to write this down with me. So this says 12 less than K. Than. I'm going to underline it when I see than. I want you to focus on this term K. 12 less than K means we're starting out with K and we're taking 12 away from it. 12 less than K. Somebody has K dollars, you've got 12 less than them, so we would do a little subtraction problem to figure out how much money you have. Over here, 5 more than J. Well, more is an addition problem, addition word. So I'm going to start with J. Somebody has J dollars, and I give you 5 more dollars than them. So see how the than tells me to turn around those words, turn around the order, J plus 5. See if I can find a nice yellow marker here. Yep. All right. Again, B more than P. That tells me that we're going to start with P. More tells me we are adding B to it. So that would be how we would write B more than P. You start off with P and we add B to it. And last but not least, F less than 19. That means we are starting with the 19 and we're taking F away from it. Okay, very important words there. Make sure you know that than is super important. It is our turnaround word. It flip-flops the order and puts that first number or first term at the end. So let's go through some of these examples here. 3 more runs than the Pirates scored. I see a than. Than tells me to focus on the Pirates first. I'm going to use a P to represent their score. 3 more than P is taking that P value and adding 3 to it. $11 less than Martha spent. How much did Martha spend? I don't know. I'll use a variable there. $11 less than that is M minus 11. Number 7, a number decreased by 10. No than here, so the order is exactly how it comes in the problem. The number is unknown, so I'll use a variable to represent that. And I'm going to decrease it by 10. So I'm going to take away that 10. 8 says 12 more than, okay, than, another one here, more than double a number. Okay, so we're going to start off with double a number. So that would be 2 times a number. And we're going to write 12 more than it, so we're going to add 12 at the end. Okay, 12 more than double a number. Number 9, the quotient of 5 and F. Quotient is a division word, so that tells me I'm going to divide. When I do quotients in 7th grade, I want to write them as a fraction. So there's my nice little fraction bar. The quotient of 5 and F means 5 goes in the numerator, F goes in the denominator, and that's how we're going to write that fraction division problem. Number 10, the product of a number and 3. Product is a multiplication word. I don't know what the number is, so I will use n, and I am going to multiply, because that's what product tells me to do. I'm going to multiply n times 3. Okay? Make sure you review these and make sure that you are making a big deal out of the word than whenever you see it. Underline it, make it stand out, because you know that whatever comes before than is going to end up at the end of your algebraic expression. Last set of questions here. I think I have these numbered a little bit goofy now that I take a look at this, but just make sure that you know which numbers they are. I think they should be 11, 12, 13, 14, 15, 16. Sorry for that. Let me fix that real quick. 11, 12, 13, 14, 15, and 16. There we go. It makes me happier. Solve these with mental math. I'm just going to give you the answers and you can check them yourself. So G equals 6. What number can we take away from 16 to get 10? That number is 6. You do want to write the full solution here. G equals 6. Number 12, 49 plus F equals 51. Well, what number can I add to 49 to get 51? That number is 2. F equals 2. 13, 4G equals negative 28, so I'm multiplying here. So I'm going to multiply 4 by a number and get a negative. That means that G has to be a negative, because a positive times a negative is a negative. 4 times what number gets me that 28? That's a 7. 14, I've got 9 minus K equals 5. What can I take away from 9 to get 5? That's a positive 4. S divided by 3 equals 20. So what number can I divide by 3 to get 20? That would be 60. And last but not least, 10 minus A equals 17. So this is a little bit of a weird one. You're taking a number away from 10 but getting something bigger. The only time that happens is if you're taking away a negative number. So if we If A is negative, we're going to be adding a line, changing the sign. So really we're asking 10 plus what number gets me 17, and that's going to be a 7 there. So the reason it was negative is because if we're taking something away but getting a larger number, that means it's got to be subtracting. Okay, check those out. Ask any questions in class about this. Make sure that we're feeling good about that terminology, especially the word than.